The periodic law. Mendeleev developed his periodic table before the discovery of protons. He did not know that all atoms of an element have the same number of protons. He did not know that atoms of two different elements could not have the same number of protons. In the modern periodic table, elements are arranged by increasing atomic numbers of protons. Figure 6 shows one way the known elements can be arranged in order by increasing atomic number. Periods. Each row on the table, elements in figure 6 is a period. Period 1 has 2 elements. Period 2 and 3 have 8 elements. Period 4 and 5 have 18 elements. Period 6 has 32 elements. The number of elements per period varies because the number of available orbitals increases from energy level to energy level. To understand the structure of the table, think about what happens as the atomic number increases. The first energy level has only one orbital. The 1 electron in hydrogen atom, the 2 electrons in a helium atom can fit in this orbital. But one of the 3 electrons in a lithium atom must be in the second energy level. That is why lithium is the first element in period 2. Sodium, the first element in period 3, has 1 electron. The metals in groups 3 through 12 are called transition metals. Transition metals are elements that form a bridge between the elements on the left and the right sides of the table. Transition elements such as copper and silver were among the first elements discovered. One property of many transition metals is their ability to form compounds with distinctive colors. The How It Works box on page 137 describes the use of transition elements in the production of colored glass. Some transition elements have more properties in common than elements in other groups. This is especially true of elements in the lanthan and acetane series. These elements are so similar that chemists in 1800s had difficulty separating them when they were found mixed together in nature. A compound of erbium and oxygen was used to tint the lenses shown in figure 11. Nonmetals. In figure 7, nonmetals are represented by yellow boxes. As their name implies, nonmetals generally have properties opposite of metals. Nonmetals are elements that are poor conductors of heat and electric current. Because nonmetals have low boiling points, many nonmetals are gases at room temperature. In fact, all the gases in the periodic table are nonmetals. The nonmetals that are solids at room temperature tend to be brittle. If they are hit with a hammer, they shatter or crumble. Nonmetals vary as much as in their chemical properties as they do in their physical properties. Some nonmetals are extremely reactive, some hardly react at all, and some fall somewhere in between. Fluorine in group 17 is the most reactive nonmetal. It even forms compounds. Group 17 is the most reactive nonmetal. It even forms compounds with some gases in group 18, which are least reactive elements in the table. The toothpaste in figure 12 contains a compound of nonmetal fluorine and the metal sodium. This compound helps to protect your teeth against decay. Metals. In periodic table in figure 7, metals are represented by green boxes. Metals are elements with properties that fall between those of metals and nonmetals. For example, metals are good for conductors of electric current and nonmetals are poor conductors of electric current. A metal's ability to conduct electric current varies with temperature. Pure silicon C and germanium Ge are good insulators at low temperatures and good conductors at high temperatures.
Atomic mass. There are 4 pieces of information for each element in figure 7. The name of the element, its symbol, and its atomic number, and the atomic mass. Atomic mass is the value that depends on the distribution of an element's isotopes in nature and the masses of those isotopes. You'll use atomic masses when you study chemical reactions in Chapter 7. Atomic mass units. The mass of an atom in grams is extremely small and will not be very useful because the samples of matter that scientists work with contain trillions of atoms. In order to have the convenient way to compare the masses of atoms, scientists chose one isotope to serve as a standard. Recall that each isotope is the element of a different number of neutrons in the nuclei of its atoms. So the atoms of 2 isotopes have different masses. Scientists have assigned 12 atomic mass units to the carbon-12 atom, which is 6 protons and 6 neutrons. An atomic mass unit, AMU, is defined as 1/12 of the mass of the carbon-12 atom. Isotopes of fluorine. In nature, most elements exist as a mixture of 2 or more isotopes. Figure 8 shows that the elements of chlorine have the symbol Ci, atomic number 17, and atomic mass of 35.458. Atomic mass units. The unit for atomic mass is not listed in the periodic table, but it is understood to be the atom. Where does the number 35.453 come from? There are 2 natural isotopes of chlorine, chlorine-35 and chlorine-37. An atom of chlorine-35 has 17 protons and 18 neutrons. An atom of chlorine-37 has 17 protons and 20 neutrons. So the mass of an atom of chlorine-37 is greater than the mass of an atom of chlorine-35. Weighted averages. Your teacher may use a weighted average to determine your grade in a weighted average. In a weighted average, some values are more important than other values. For example, test scores may count more heavily towards your final grade than grades on quizzes or grades in homework assignments. Figure 9 lists the atomic masses for 2 naturally occurring chlorine isotopes. If you add the atomic masses of the isotopes and divide by 2, you get 35.967, not 35.453. The value of the atomic mass for the chlorine in the periodic table is a weighted average. The isotope that occurs in nature about 75% of the time, chlorine-35, contributes to 3 times as much of the average isotope that occurs in nature at 25% of the time, chlorine-37.
Class of elements. The periodic table in Figure 7 presents 3 different ways to classify elements. First, elements are classified as solids, liquids, or gases, based on their states at room temperature. The symbols for solids are black, the symbols for liquids are purple, the symbols for gases are red. Second, elements are divided into those that occur naturally and those that do not. All but 2 elements with atomic numbers at 1 through 92 occur on Earth. Elements with atomic numbers of 93 and higher do not occur naturally. The symbols for these elements are in white. In Chapter 10, you will find out how elements that occur in nature are preceded. The third classification system puts elements into categories based on their general properties. Elements are classified as metals, nonmetals, and metals. In the periodic table, metals are located on the left, nonmetals are on the right, and metals are in between. Metals. The majority of the elements on the periodic table are classified as metals. In Figure 7, they are represented by blue boxes. Metals are elements that are good conductors of electric current and heat, except for mercury. Metals and solids at room temperature. Most metals are malleable. Many metals are ductile, that is, they can be drawn into the thin wires. Some metals are extremely reactive and some do not react easily. One way to demonstrate this difference is to compare the behavior of gold and the behavior of magnetism. When these metals are exposed to oxygen in the air, gold remains shiny because it does not react with the oxygen. Magnesium reacts with the oxygen and quickly dulls. Figure 10a shows one magnesium coal that is dull and one that is shiny. Figure 10b shows one used for metal with a shiny surface.
Number 1. What information about an element is usually provided within each square on the periodic table? Number 2. Which property is used to arrange elements on the periodic table? Number 3. What does the group number in the periodic table represent? Number 4. What is position on the periodic table related to the chemical properties on an element? Number 5. How are the elements in a given group related? Number 6. What are the metals, nonmetals, transition metals, and metalloids located in the periodic table?